Hello students! I want to work with you one last trigonometric substitution problem. So we're going to evaluate the indefinite integral 1 divided by 25 minus 16x squared all raised to the 3/2 power. Now at first it looks pretty simple, right? We'll just do a straight up trigonometric substitution because U substitution won't work. But what's the kicker here? What makes this one different than any problem we've done in class or on our homework thus far? Do you notice that there's an extra number in front of the x squared? Right? Normally our pattern would be an a squared minus x squared. But we've got something extra in front of the x squared. So what are we going to do to deal with it? Well, I'll tell you what my brain says. And see if this doesn't make sense to you. My brain says, okay, all right, let me look at this bottom here. I have a 25 minus 16x squared. And I know 25 is 5 squared. And I know 16x squared is actually 4x squared. All of this is being raised to the 3/2 power. And we'll deal with that in a minute. But let's keep focused now. So normally, if we see a squared minus x squared, we would make the substitution x equals a sine theta. So what do you think you want to make a substitution now? What do you think you'd like to do for this one? Well, I think 5 is still going to be my a, but instead of just doing an x, I've got a 4x. And so this is what I do. So instead of just having an x, I have a 4x. And so when I make my substitution, instead of saying x equals a sine theta, I actually write 4x equals a sine theta. No, excuse me, not a. 4x equals 5 sine theta. And that's how I do my substitution. In other words, x dividing both sides by 4 is just going to be replaced by 5/4 sine theta. So everywhere I see an x, I'll replace it with 5/4 sine theta. And every time I see dx, I'm going to replace that with 5/4 cosine theta d theta. That's how I do it. I kind of make the same pattern, but instead of just having an x squared, I turn it into 4x. See if that works. Let's see how this works. Okay, let's see how this goes. So we have the antiderivative of 1 over, and now I'm going to make my conversions right now, okay? Everywhere that I see an x, I want to replace it with 5/4 sine theta. Everywhere I see a dx, I want to replace it with 5/4 cosine theta d theta. So we get 1 over 5 squared, right, minus, and then I've got 4, and in place of x, I'm putting 5/4 sine theta, and that's all getting squared, raised to the 3/2 power. And in place of dx, whoa, I almost just wrote dx down. In place of dx, we're replacing that with 5/4 cosine theta d theta. All right. So let me come down one more line and let's see what we've got. We've got 1 over, and that is 5 squared, or 25, minus, and notice, because of the way we chose our x value, those 4's cancel, right? That's kind of cool. And we are just left with 5 sine theta squared, or 25 sine squared theta in that bottom, raised to the 3/2 times 5/4 cosine theta d theta. I think at this point you guys could actually finish this if you wanted to. I'll go a little farther and see if I can't work this out just a little bit. So if you want, you could stop this video, finish this up at this point, because that was the new part. But for those of you that are still struggling a little bit with trigonometric substitutions, let me walk through this just so we can get the same answer at the end. In either case, it's good to pause the video and try to work it out on your own. It really is important to try and work it out on your own. I'm going to pull out my 5/4, and I'm going to be left with cosine theta d theta. In the bottom, I'm taking out that common factor, right? In the bottom, we've got that common factor of 25. And so I've got a 25 coming out, leaving me with 1 minus sine squared theta. And we like that. All of that to the 3/2 power. But we like that, and the reason we like that is because 1 minus sine squared, we know, converts right into cosine squared. And we've got this extra square root out there, and so everything's going to turn out really nice here as we go forward. So let me put one more line here at the bottom, okay, one more line. So what do we have? We have the antiderivative of, we have 5/4 times the antiderivative with a cosine theta d theta on top. On the bottom, we've got this 3/2 power. So what are we doing? We're taking a square root, right? And then we're cubing that square root. And underneath, we've got the 25 cosine squared. And let's see what happens. 5/4 in front. Cosine theta's in the numerator. In the denominator, we're taking a square root of 25, and that's just giving us a 5. We've got a square root of cosine squared, and that's just giving us a cosine. But we can't forget that power 3 here, and so all of that's getting cubed. And when I put that all together, let's see, 5 cubed in the bottom, so I have a 5/4. I'm going to pull out that 5 cubed and be left with an integral of cosine over cosine cubed. Now this is nice. Isn't it? Look at how nice this is. Things are going to cancel for us. And again, hopefully you've paused the video, you've stopped and tried to work it out yourself, okay? And you are getting the same thing that I'm getting. We're going to cancel those extra 5s, so I'll have a 5 squared in the denominator. We're also going to cancel those extra cosines and be left with a cosine squared. And so what does that put us all into? Well, let me turn the page now on this one. What does that give us? So let's see if you're getting the same thing I am. So we've reduced it down, and I get, as a coefficient in front, 1/4 times 25. And then that's times the integral of 1 over cosine squared theta d theta. And are you guys like jumping up and down for joy? Do you see what's going on here? Hang on a second. So 1/4 times 25 is just 1/100. What about 1 over cosine squared? Yeah, it's an even power of cosine, but cosine's in the denominator. So what are you thinking? 1 over cosine is secant, right? And so what is 1 over cosine squared? That's just secant squared. And this is one of those things that we have memorized, right? The antiderivative of secant squared is just tangent, right? Antiderivative of secant squared is tangent. And so this is simply 1/100 tan theta plus c as our final answer. I mean, it can't get more beautiful than that, right? All right, so very last step, what do? We need to convert this tangent of theta into our x's. And so I put the original substitution that I made where I wrote 4x equals 5 sine theta. And remember, then we solved for x and made it 5/4. But if we use 4x equals 5 sine theta and we divide both sides by 5, notice you get a relationship for just sine theta. which is 4x divided by 5. And that's the relationship that I like to use when I draw my right triangle. That's how I like to use my relationship. So sine, remember, is opposite over hypotenuse. So once we set up our right triangle, I would label the leg, vertical leg, 4x. I would label my hypotenuse 5. And then down here, the other leg becomes 25 minus 4x squared, or 16x squared, that pattern we see. And now I can write down what my tangent is. It's a piece of cake, right? 1 over 100 times tan theta is simply 1 over 100 times, and now tangent is opposite over adjacent, so it's going to be 4x over the square root of 25 minus 16x squared. And you're okay to leave that square root in the denominator. I'll have no problems with that. If you're feeling super happy and you want to make one extra cancellation, you see the 4 will cancel down with the 100. So we could do one more cancellation there to make it really nice and sweet and make it x over 25 times the square root of 25 minus 16x squared plus c. That's our final answer, and if we take the derivative of this, we should get what we started with, which is 1 over the square root of 25 minus 16x squared to the 3/2 power. All right, guys, I hope you're getting used to these trigonometric substitutions, and they're starting to get much easier. If you have any questions at all about any other problems on your homework, please go ahead and email and reach out to me. See you guys all in class.